Hello everyone. We're going to get started here. We're going to talk about loops or loop structures, specifically about while loops, which is a new topic. I know we've talked about for loops already this semester, but in this particular lecture, we're going to chat about using while loops instead. So let's go ahead and get started. So while loops are a different type of loop structure that allows us to repeat until a condition changes. So for example, if I have a variable called x, and I don't know what its value is, but I want to continue repeating a loop, a sequence of commands until x is greater than 100. And that's called a while loop, and it's repeat or loop until a parameter changes or a value changes. This is for when we need to repeat a series of commands, but we don't know how many times it's going to be. In a for loop, you have a specific number of times it's going to be repeated, and you know that number when you start the loop. In a while loop, you have no idea. It might repeat 5 times. It might repeat 5 million times. You're going to repeat until a condition changes that tells Python when to stop repeating. So we'll talk about the types of loops in Python. We'll talk about some Boolean expressions in loops, and Booleans are one of the topics we're talking about this week, which is true and false values stored in a variable. We'll implement a while loop using a counter. So for loops usually use a counter, right? You've got a variable like for I in range 10. I is the counter, and it's assigned the values, the increments from 0 up to, but not including the end of our range, 10. But we can do a while loop with a counter, and we're going to talk about the possibility of setting up a while loop that will never end, an infinite loop. Judgment Day, it's the end of the world, your computer will never stop looping. It might feel like that. But we'll talk about how to deal with that, and we'll talk about some everyday programming problems. We've got some examples using while loops of how to set those up, and it's a challenge for you to write that code, and then we'll go and review that. All right, so we've talked about for loops so far, and for loops are when we know specifically we've got a sequence of values. We want to step through or increment through that sequence of values, like counting from 0 to 10, or I've got a list of values, and I'm going to look through each value in the list. A for loop has a fixed number of times it's going to repeat, and it's only that number of times it's going to repeat. A while loop is different. We'll look at how it's different here in a little bit, but which type of loop you use depends on your particular situation and your needs. If you're writing an interactive program with a user and they're controlling the program with mouse clicks, for example, you don't want to just repeat a certain number of times. You want your program to continue looping or repeating until the user says quit, or until they click on the stop sign, or whatever it is that they're doing within their program. So we use while loops for that. The while loop, at the top of the while loop, it checks to see that a condition is true. So as long as that condition is true, then it continues looping the body of code. So if you said, for example, while x is less than 10, if x was 11 at the very beginning, this loop would never execute, because it's only going to execute the loop, in this case, while x was less than 10. If you said while x is less than 10 and x was 0, it would do the loop at least one time until x was no longer less than 10. The end condition is a Boolean expression, like we use in an if expression, an if statement, that resolves as true or false. So it's while this end condition is true. And the way you make your loop stop is somewhere inside the loop, you change the variables so that when it comes back up to the top of the loop and it looks at its end condition, it knows to stop. In the textbook, there's a couple of examples where they start with a while loop that says while true, and then inside the loop, they use something like a break statement. I don't want you to use that format at all. I always want you to write a while loop with an end condition. While I haven't clicked the exit button, while I've not entered in -1, while I don't type in goose when you're playing duck, duck, goose with your computer. Always have an end condition on your while loop. And that way, when that end condition is false, the loop will stop. So here's a good example. As long as the count variable is less than 9, I want to repeat. So if this is true, count is less than 9, the loop executes. It repeats at least one time. Once it's false, the loop stops. So I start off, I assign 1 to count, count equals 1. while count is less than 9. So at this point in my program, count is 1. It is less than 9, so this is true. This is my end condition. Print the count is, whatever the count is. So the first time through, count is assigned 1. As long as count is less than 9, do the loop. So I'm printing the count is 1. Then count equals count plus 1. What is count now? 2. So it comes back up to the top of the loop. Is it still less than 9? It is. So it's going to print the count is 2. So far, this little program is going to print the count is 1, the count is 2. It's going to keep looping. The count is 3, the count is 4, the count is 5, 6, 7, 8. What happens after it prints the count is 8? It increments the variable by 1, comes up to the top. Is count less than 9? Well, 8 plus 1 is 9. It's not less than 9. So this is then false, and the loop stops. So what actually gets printed? Well, the count is 1 all the way up through the count is 8. That's it. That's all that gets printed. The loop stops. So in this while loop, we're using the while loop and we're using a counter to control the while loop. So here's a little example using a logic flow. Count equals 1. As long as count is less than 9, if that's true, first time through it is, print increment count. Is it still less than 9? True. Print increment count. Keep going until this is no longer true, basically when count gets to 9. Then end the loop. So this is a logic flow diagram. Triangles are decisions, or I should say diamonds are decisions, and these rectangles are where it executes a statement in your program. And the arrows show the flow of logic. So count is 1, it prints it, it increments it, count is 2, 3, 4, 5, 6, 7, 8. Come back up, count equals 9, this is false, ends the loop. So the end condition is tested at the very top of the loop. So what happens if the end condition is false the very first time the while loop is executed? It doesn't run the while loop at all. It doesn't run it at all, it stops immediately. This is called a pre-test loop. You're testing the condition before you run the loop. And if the loop is initially false, then the body of the loop, the commands inside the loop, never happen at all. So number equals -1. While number is less than 0, number equals float input, enter a positive number. So I'm converting the input to a float. If the number they enter is greater than 0, then break. So this is called a post-test loop. You're going to see the examples of these in the textbook. I strongly discourage you from using them. It is sloppy programming to use a break statement within your while loops. I would suggest you don't use this at all. In this particular case, what can happen is you just loop back up and it would have ended the loop anyway, right? If I entered in, for example, 10, then when it came back up here, number would not be less than 0 and the loop would have ended anyway. So we can do this, and it does work, but it's extra lines of code we don't need, and it's not really good programming principles to do it this way. So stick with pre-test loops as opposed to end of test loops. All right, and you want to beware of the infinite loop. A while loop does not require that the condition is ever false. You could set up a while loop and it will run wonderfully forever and ever and ever and ever without ever stopping if the while condition is never actually false. So for example, count equals 1. While count is less than 9, print the count is, it'll print 1. And then we subtract 1. So now count is 0. While count is less than 9. Is 0 less than 9? Yes. The count is 0. Then it's -1, -2, -3. This is an infinite loop because it never ends. Or what if I was checking the count variable, but I wasn't incrementing it, positive or negative? The loop would never end because the variable that I'm using for my end condition never reaches an end point. So you want to be careful about that. This is what's called an infinite loop. You will eventually write one on accident or on purpose, I don't know, and you'll see how that works. So what do you do when you have an infinite loop? Well, first you try pressing Control-C. hold the control key down, press C on your keyboard. That should stop your program, but what if that doesn't work? Well, close the idle window, end the idle window, just terminate it. You'll get a confirmation message. Are you sure? Yes, done. If that doesn't work, use your task manager and force idle to shut down. And if all else fails, go find the circuit breaker in your building and cut the power to the whole, actually don't do that. Don't do that. This is not the actual Terminator Judgment Day here. You ought to be able to just stop your program with Control C or closing the idle window or using Task Manager to close the application. It's very, very simple to close it down. You're in full control of your idle window at all times. All right, so let's try a few of these out. Let's say we're going to write a while loop where we accept input from the user until they enter the number 1. If anything else is entered, the while loop just repeats. No, it doesn't do anything with what they enter. Just keep looping until, excuse me, keep looping until they enter the number 1. So let's take a look at this. If you were to write this yourself, how would you set that up? How would you start it out? Let's start with some pseudocode. I'm going to accept input from the user until they enter a 1. If anything else is entered, the while loop just repeats. So first thing I'm going to do is define my main function. I've got my pseudocode here. Then I'm going to get the first number from the user. And my end condition is as long as they haven't entered a 1, right? Then take another input from the user. As long as it's not a 1, then take another input from the user, take another one, take another one. Notice I've even indented my pseudocode here. I strongly encourage you to do that. This helps you remember your indentations for your program as well. So how do I define the main function? We've done this a bunch of times this semester. Well, it's just def main, right? Define main. So indented below that, I need to get the first number. I don't really care what they type in, right? So, but I can use the input statement and I need to assign that to something. So how about number equals eval input, enter the number. Eval, so that I can check to see that it's a number, right? Could be a float, could be an integer, I don't care. As long as we get a number. Now I need to write my while loop. I need to repeat until number is a 1. So I'm not saying repeat while number equals 1, because that's only repeated if it is 1, right? I want to say repeat as long as it's not 1. So while number is not equal to, remember this from our Boolean comparisons, while number is not equal to 1, I'm going to keep looping. While number is not equal to 1. What happens if they type in 1 the very first time? Well, this loop's never going to run and the program will be over. But if they typed in something else the first time, it's not equal to 1. So we prompt them for another number. Eval input, enter the number. This looks weird. I'm entering the same prompt twice. That's odd. We'll look at a way to avoid that here in a little bit. But this way, we define our function, we get a value from the user. As long as that value does not equal 1, we just keep asking the user for more values. And as soon as they type in a 1 for a response here, the while loop ends, the function ends, we're done. So what happens when we execute this program, Python looks down this left margin. I've defined the main function. There's commands in there. I don't have to run them yet. Call the main function. It goes up and actually executes the command. So Python runs down the margin here. Yes, there's a function called main defined. Oh, I'm going to call it now. It goes up and runs it. And it prompts the user for a value. It checks to make sure that that is not equal to 1. If it's not equal to 1, it prompts them for another number and then keeps looping, prompting for numbers until they type in 1. All right, well, that's our first example. Let's look at another example. How about this one? I mentioned earlier, what if you played Duck, Duck, Goose with your computer? You know that children's game, right? You go around, duck, 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 goose. What happens when you say goose and touch somebody's head? You have to start running, right? So you got to run, and I want you to tell me how many times you said the word duck. So accepted input from the user. If it's anything other than duck or goose, it should loop back to the prompt. If it's duck, just prompt them for something else. If it's duck, increment our counter by 1, so we know how many times I said duck. and continue looping and prompting them. So we're basically going to accept anything from the user until they type the word goose. Once they type the word goose, print run and the number of times they typed in the word duck. So if they said blue, red, green, duck, black, goose, how many times do they say the word duck? Once. The program would say run, duck was entered one time. Yeah? Let's see how to do that one. Let's try that one. Let's jump ahead here. So first thing I want to do is define my main function, and I'm going to have a variable for my enter string, and I want to initialize it as empty because I'm going to use this string as to check what word they entered. Did they type in duck? Did they type in goose? Or whatever. Then I'm also going to initialize a variable for how many times they typed in the word duck. So I'll call this variable ducks, and I'll say that it starts at 0. So I've got an empty word, and I've got ducks at 0. And here's why I use the empty word, because I'm checking that word. I'm specifically checking it in lowercase. This is so that if they type in duck in all lowercase or in all uppercase, it doesn't care. Lowercase, uppercase makes no difference, okay, if I do this. So while the lowercase version of the word is not equal to goose, if I had not initialized this string, then this statement would have caused an error because I was asking about a string that didn't exist yet. So I'm initializing the string. So the string is an empty string. While the lowercase version of that is not equal goose. Does this equal goose? No, so my loop will start. I prompt the user, enter a string. They'll type something in. Dock. They type in D-O-C-K, dock. If it's the word duck, then increment my counter. So is it D-U-C-K? Well, if they typed in D-O-C-K, then it's not. But I won't increment my counter. But if they typed in duck, D-U-C-K, I'm going to increment my counter variable by 1. Now, what do I do next? We'll go up, check to see if it's goose. If it's not, prompt them for a new word. Keep doing this loop. Increment duck if they said duck. If they don't say goose, keep prompting them. So they could type in any words they want as long as they don't type the word goose. When they type the word goose, the loop has ended. And we're going to print run. Duck was entered this many times. And using my .format command, I insert ducks right here. This is this variable. It starts off as 0. So the more times they type the word duck, the more times are going to be listed here. If I typed in duck 5 times and then I typed in goose, it's going to say run. Duck was entered 5 times. And that's it. That's the whole program. There's actually almost more comments in this program than there are lines, but that's okay. It's a really good idea. Start with our pseudocode comments and then work our way through. Let's come back here to our tryout. The third option here is accept values from the user until they enter something that's not an integer, right? So they could type in 4.7, or they could type in hello, or just a blank line. Keep accepting values from the user until they type in something that's not an integer. If they type in something that's not an integer, print the number of values they did enter, so the number of integers they entered, the average of those integers, the sum of them, the highest and the lowest integer as well. So let's say I type in 5, 6, 8, 10, 2, 4, 1, Bob. Bob is not an integer. So I need to get the number of integers I entered in, the average of those integers, their sum, right? Add them all up. The highest and the lowest integer that I entered. How am I going to do that? Well, a while loop makes sense because we don't know how many times we want to loop and get another value. Something else that might make sense is a list. If I use a list, I can store all those integers in a list, and then I can do my math calculation on them as well. And there's some little shortcuts for that you're going to see here in a minute. So let's take a look at this tryout. So here's my pseudocode. I start by defining my main function, and I initialize an end condition. In my duck, duck, goose, it was the word being an empty string. In this one, I'm going to use a true false condition that I can initialize. And also I'm going to create an empty list. I'm going to use this list to store those integers. I'm going to loop until the condition is false. So initially, the condition is going to be true, and I'll keep looping until the condition is false. And then here, I'm going to use try except. It's something that's in this chapter, something that we talk about in the textbook, in your conditionals and decision structures, but also in chapter A of the textbook. A try except is where we try to run a command, and if an error occurs, we do something different. It's handy because it handles those input errors, right? If it works, then append the integer to the list. If not, then set the condition to false so that this loop doesn't keep repeating. Then we're going to calculate the required values and display the results, and in the end we call the main function. So we start off, define main. Then I've got this variable called COND, which is just short for condition. Condition equals true. And my list of numbers is empty. Let's start with initial empty list. While condition. So this is a shorthand way of saying while something is true. I could also say while con is, remember comparisons, Boolean comparisons are double equal signs. So while con is equal true. That works as well. But this, while a Boolean variable or while the variable is equal to true, those are the same statement basically. So while condition. Try, so this is execute a statement and see what happens. Number equals int input, enter the number. If I typed in Bob, that would give an error message. If it didn't give an error message, if it worked, it's going to append the integer to a list. If it did give an error message, this except portion is going to be run. It's going to set condition equals false. It's going to, this ends, which ends the loop. We're going to count equals the length of my numbers list. So I've been appending numbers inside this loop. When the loop stops, whatever the length of the numbers is, I'm going to assign to count. And if count does not equal 0, so if there are numbers in the list, nsum is the sum, or the total, of the numbers in the list. Sum is a list function. It takes a list of values and adds them up. So that's pretty handy. Max is a list function, a sequence function, and it just finds the highest value. So if max finds the highest value, well, min is going to find the lowest value. So we got min. These, by the way, are in the textbook, in the list section. And if I take the sum of all the numbers in the list and divide it by the count, the number of numbers in the list, I'm going to get the average, right? So average equals nsum divided by count. Now I just have to display my results. Print count, count, average, average, sum, nsum, high, high, low, low. And in the end of my program here, remember we go down the left margin. Define the main function. There's something in there. Call the main function. Now it starts running it. And it executes all these statements, prompts the user for values, saves them all in a list, appends them to the list, and eventually calculates the statistics and prints them. So this would actually do that. And you're going to have a lot of programs this semester where you either read values from a data file or you prompt the user for values, much like Lab 1-3 or even 2-1. You're going to prompt the user for something, store it in a list, and do something with it. And that's a key. That's a key. So make sure that you put these kind of programs in your back pocket like a tool, like a toolbox, right? All right, well, that's it for this particular lecture. We had 2 other lectures before this one, of course. Take the quiz for this one. Go ahead and get started on your CodeLab homework. That's due Wednesday, Wednesday. And then your lab assignment, programming exercise 2-2 due Friday, and the lab assignment due the following Monday. Have a good week. Take care.